All right, let's review a little bit of information about circuits and the size of the electric current and energy that is produced. So notice that we watched a video here the other day, and we have two different circuits set up. The first one has one battery, which is 1.5 volts. And notice that the light is pretty dim. The light is dim. But in the next picture, we see three batteries, and the light is very bright. And so we see that by increasing the amount of electric current that is flowing through the circuit, we increase the energy output, and in this example, the energy was given off as light. So remember that increasing the current, the size of the current, or the volts, will increase the energy that is produced. So we say that this is a directly proportional relationship. If one increases, the other one is going to increase. Now, vice versa, if we started out with 4.5 volts and we decrease the current to 1.5, then we are going to decrease the energy. So just remember that the size of the current is directly proportional to the energy produced. If you increase one, you're going to increase the other. If you decrease one, you're going to decrease the other. All right, now we're going to look at open and closed circuits. In an open circuit, notice that there is a gap here. There's a gap between the metal, and so that means electrons cannot flow, because the electrons cannot get from this point to this point if there is no metal connecting them. So that's why the bulb is not working. Now, when we look at the closed circuit over here, you see that there is a piece of metal connecting these two sides, and so the electrons can flow. So electrons, or the closed circuit, is what is required for the electrons to flow, and that's why the light is on in a closed circuit. And then the last thing that we talked about with circuits were the difference between series and parallel. So in a series circuit, there's only one path for the electrons, and all lights are either on or off. There's no way to control turning one of them off and leaving the other ones on in this kind of circuit. So if this bulb goes out, then all the other ones are going to go out in a series circuit. In a parallel circuit, there are multiple paths for the electrons to flow. And so this allows you to control the lights separately. All right, so if this one goes out, I can still have these two on. So that is an advantage. Like most of the newer Christmas trees, your bulbs are set up in a parallel circuit so that if one of them goes out, the other ones are still going to work.